Let's add our mixture components and fix some problems that we have in dispersion. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, as you saw, we were talking about adding a sort of component to our dispersion that will define the things that will be in the dispersion. Olama was suggesting that we should have this component class. However, I did make the decision to rename it to mixture component because when we are talking about components inside dispersion, we see that inside the implementation, we have these components and component maps, and they are data components. To differ from data components, I made the decision that we need to call them mixture components. I did define this enum beforehand, and yes, all of these names and descriptions came from chat with AI. Something that I need to mention is that you may see duplications between the mixture components and the dispersion type. For example, the gel, the colloid, and few other things maybe here are exactly the same names that you see inside dispersion type. The thing is that when we are talking about dispersion types, we are talking about a complete physical form that carries some specific behavior and physical aspect. But when we are talking about a mixture component type, we are talking about one thing inside dispersion. For example, in case of colloid, yes, we can have a dispersion type of a colloid, and inside that, we can have a component that is colloid itself. Or for example, inside suspension, we can have colloids. And those colloids are the particles that are suspended inside dispersion. Because of that, you see the colloid name both in the type for the dispersion and the type for the mixture component. And you should dissect these two from each other. Anyway, the mixture component type is just a simple enum. So I didn't waste your time typing these things and talking about different types. Java doc is there so that you can read it. However, when it comes to mixture component class, we need to talk. The mixture component can be a class or a record. The difference is that records are immutable, meaning that the first time you create the record, you can't change the values. And that is exactly what I want for a mixture component. Let's talk about a practical example in a mod, because then we will know how we should define this. In a mod, I want this type of dispersion. For example, let's talk about saltwater solution. So the dispersion type is a solution. We will have two different components inside this solution, water and salt. Water is a liquid, it's a solvent, and many other different aspects of a component. Also, salt is solid, is particle, is the solute, and different aspects of the component again. However, when I'm defining this salt water, I'm defining a type of a dispersion. I'm not defining the number of items inside the amount of water. I'm not defining how much water I have, or I'm not defining how much salt I have in this water. All I'm defining is that, hey, this is the component called water, and this is the component called salt. And these are the physical aspects of each component. Because of that, when I'm defining the dispersion, I'm not defining an example of a dispersion. I'm not defining a specific salt water with a specific amount of salt in a specific amount of water. I'm just defining the type. And here, the component is exactly the same thing. It's a type of a component inside the dispersion. Because of that, normally when you are defining the component, you will not change the values of that component. Right now, I'm starting with a bare minimum. Maybe when I'm done with this API and I'm not recording any video, I will come back and revisit the class, and maybe I change few things. For example, here I'm thinking about adding a double as an amount, but then when I think about everything that I talked so far in the video, I think that amount is not something that I should define here in a component. However, different things may be able to sit here to define a component. And those are physical aspects of a component. Later, you will see that I have a stack for dispersion variant, like fluid stack, like gas stack that I have in that record, we will define the number of things and the amount of things that we will have for a practical use in a recipe, for example, or in a machine. However, here, all I want is the ability to define a mixture type. We start with a string for the name. For time being, I will add a double called amount. As I said, I'm not really sure if I will keep it or not. Then I will add a set for that mixture component type, and I will call it types. Why I'm using a set is that a set is immutable again. So every time I want to change the set, I need to redefine a new record. Now, I will add documentations on top later when I'm not recording. However, I want to progress fast. This is the block of code that will be checked whenever you are defining a record. It's just like a constructor, but not really a constructor. It's happening inside the construction time of the record. And normally in this block in records, you just do some sanity checks. For example, we say if name equals to null, or name that is empty, name shouldn't be empty, so we will throw a new illegal argument exception saying that name cannot be null or empty. Then I will do another sanity check, so we say if the amount is less than 0, so if we are giving a negative number, mixtures can't have negative numbers, at least for time being, so we will throw another new illegal argument and we say amount cannot be negative. The amount role was like I want to define the amount of a mixture in a unit of dispersion. As I said, later down the road, I may drop this amount. I may add some more physical components of a mixture type. You can use it, you can ignore it. However, for time being, just follow the example because we want to get the API up and running, and then we can come back and add things later if we want to. So we say objects dot require not null the types, and the message we want to send in is types cannot be null. And I have a typo here. After that, the last sanity check is that if the types dot is empty, so it's not null, but it's empty, I want to throw a new illegal argument. I was thinking if I want to drop this sanity check, but then I thought that, you know what, a mixture component should have a type. It can't be unknown. Type set cannot be empty. We are done with our sanity checks. Finally, when we are defining a mixture component, I'm sure that everything is working. From this point forward, I want to have some helper methods for myself. For example, a public boolean that says has type. I want to check if a mixture type has a type, a specific type. So we will say we want a mixture component type, and we call it type, return types that contains the type. As simple as that. Then we want to get a new record if we want to change any aspect of the original one, for example, an amount, or maybe we give it a new type or completely rewrite a type system there. So we need to give back a new record. Because of that, we want to return a mixture component, and we call it with amount double new amount. By the way, if I drop the amount and add any other parameter, I will rewrite this method and replace it with new ones. Return new mixture component with the name that we had, but here we replace the new amount and the types that we had. So you see that we are returning a new record with the new values. The next one, public mixture component as the return type, and we call it with additional types. Here we want a mixture component type. At the end, without any space, I will put 3 dots, means that any number of types that we want. Let's call it additional types. We want to define a new set of mixture component type. We call it new types equals to new hash set. But as you see, we can give it a collection. We want the old ones that we have so that we make a copy of that into a new set. Then we want to loop through every additional types that we have. So I will do this dot for, and this will complete a for loop, and I will call it additional type. We say new types dot add additional type. I will remove this one. I will remove this one. And finally, at the end, we return a new mixture component type with the same name that we had, with the same old amount that we have, but now we use the new types as the thing that we want. Now let's see what it says. It says that replace iteration with bulk, add all. We convert the array to the list, and then we add all the list on top of the set. After that, I want to have another one that is returning a mixture component, but instead of adding some types, I want to completely rewrite the type system. So we say with types, and here we accept a set of mixture component type, and we call it new types. Simply, we want to do a sanity check, so we say if new types equals to null, or new types that is empty, we want actually to throw this exception, okay? Instead of types, I will call it new types. After that, we return a new mixture component. We had the name from before, we had the amounts, and now we have the new types. And that's it. So far, this class is almost complete. However, I prefer to have some additional methods at the end. I will write one of them and then I will not continue it because the rest are exactly similar with different names and different types. And then when I stop recording, I will come back and write the rest. Just as an example, I will write the first one. Public Boolean is salute. Now, this is a helper class. Basically, when I have this one on top, it's doing the main job. Because all I want to do here, we return if has type, but here we will say mixture type component called salute. And that's it. Basically, this is a sugar-coated method name for doing a method call with a custom param. So that, for example, at any time, if I have a component, I can say that is salute, and that would do the thing for me. Honestly, after this, there are not much to do with this class. However, we have things to do inside our dispersion. The first thing that we need to do here is actually add that mixture component inside a dispersion. So I will add a list of mixture component, and I will call it mixture components. After that, yes, we have lots of errors here. We want a method call that will check if we have a mixture component type and then return a list of the things that we have there. And yes, you see that I have added these handle interactions with 3 empty methods just in case anyone wants to overwrite anything. So we will return a public list of mixture component, and we call it get components by type. Here we want to give it a type, so we want a mixture component type. We call it type. We will use a streaming here. We return from the mixture components, we stream, and then we do a filtration on the stream. With the component goes into a lambda. All we are doing, we say component dot has type, the type that we want. At the end, we have, as you see, a stream, and we want a list. So what we can do, we convert it to a collection with calling the collect collectors to unmodifiable list. So it says that replace collect with to list, and that will be it. Basically now this list, I think it's immutable. I'm not sure about that one, but it should be because the suggestion was suggesting to replace it. Finally, this is the method that we needed. However, if you notice, even before this addition of mixture components, we had problems, especially here. Well, we are calling register here, and register is not what we should call. We should call of here. Inside each one of these of methods, we need to return not a new dispersion, but return a result of a register call, because we want to register the new dispersion in the system and then return it. So here, each time I have an of method, I need to replace this new dispersion to call the register. Then we have another problem, and that is we didn't define this mixture component anywhere inside our system. Here we are accepting a string ID. Basically, we are defining a mixture components that is empty. So I will say list.of, and that is returning an empty list of mixture components. Don't worry, we can add more components to this dispersion later. It doesn't change anything. Here we have just the dispersion type. Again, empty list. Here we have the heat, empty list. Here we have the heat and no dispersion type. Okay. Here we just have the stability. Here we have the type and the stability. Here we have the type, heat, and the stability. That's it for time being. Of course, I can and I will sit back and figure the counterparts for these that accepts a list of components if I want to, so that I can directly create a dispersion with an ID and the mixture components without having any other param. But again, that can happen behind the scenes. What I need to do right now is to fix my register calls, because as you see, my register calls are not really what it should be. I will accept all of these params inside each one of these register calls. And here, after creating the ID here, I will send in the rest. So dispersion type, heat, heat unit, viscosity, density, then we have stability, and finally mixture component. That should fix this call. However, final result here, after getting the ID, I need to create the dispersion using the rest of the things. So we have dispersion type, heat, heat unit, viscosity, density, stability, and mixture components. And finally, at the end, we have our system working as we intended. For example, the empty type is actually called empty. It's the type of empty, and as the mixture component, by definition, it will have an empty list without any heat, heat unit, viscosity, or anything else. Now, that's it for this class. As I said, I need to add more of these overloads for creating instances using the mixture components, but that will happen behind the scene. And right now, the only thing remaining is that inside my dispersion variant and dispersion variant implementation, I don't have anything related to these parameters. Basically, we want methods to return these. So I will get them to cheat. Then at the very end, I will paste it, and I will do this. Public space, copy it, and each time I add it in front of one of these. So that's heat unit, this is viscosity, this is density, stability, and the components. Then the last thing I do, I just put parenthesis and a semicolon. So instead of that comma, I will replace it with this. And by doing that, now I have some methods that I can override inside the IMPL. So let's do that. Copy this, go to IMPL. At the very end, maybe above these two, I will add these, and on top of each one of them, I need this override annotation. I will remove the semicolon, go to the next line, put two curly braces, and yes, it will yell at me because now it needs a return keyword with returning a thing there, but we will fix that in a few seconds. So the last one. Okay, now I will copy this dot dispersion dot, and I will return it dot dispersion type, and that will fix that one. So I will copy this whole section going back down, and this is the heat, this is the heat unit, viscosity, density, stability, and finally mixture components. If I recall, I have somewhere asking for get name. I should have it. If I don't have it, oh, I don't have it. Actually, I think I did it somewhere else. Let me see if I have it here. No, okay. Now that I don't have it, I will add it here. Actually, this is an interface. Interfaces doesn't need this keyword name in front, this public keyword in the front. So I will say string get name, and that's it. So here I will use that get name and override it and return this dot dispersion dot ID. Or I can call it get ID. Let's go with get name. Actually, when I'm using the identifier in the register, oh no, wait, that's a dispersion. This is the variant. So yeah, I will change this guy to get ID, and hopefully it did refactor it in the base because I chose to refactor on the base. So that's it. Now we can call this base infrastructure complete, although arguably I have things to do with this class, removing the amount and maybe add new things there. However, for time being, let's assume that this is complete. In the next video, we can come back and work with the storage system, add the storages, add the connector, and everything else that we had seen so far. That is a repetitive job. I can open my gas API and mimic exactly what I have there, but I want to talk about it because I want to have a complete mini series about an API system that you can write yourself. Have fun, everyone. Bye.